Example 8 asks us to express each of the following in terms of the same trigonometric function of an acute angle. Now, if you'll notice with this problem, we have the sine of 1001 degrees and the secant of 23 pi over 8. Those are pretty large, and those are numbers in radians and degrees that we haven't really dealt with yet. So I'm going to teach you how to deal with them, and then it kind of goes back to some of our previous examples on how to solve those problems. So let's understand 1001 degrees first. So what is that? Well, every angle starts at 0. If we were to go all the way around the circle, all the way around, one rotation, we get up to 136 degrees, or 160 degrees, excuse me, 360 degrees. If we go all the way around again, that's another 360 degrees. So we're now at 720. But notice that we got back to the same spot. The key to trigonometry is that you may have an infinite number of angles, but they start repeating themselves in terms of how they behave. 0, 360, and 720 are all 3 different angles, but they all end in the same place. They all have the same properties, ultimately, because of that. And so we're going to use this idea. If angles are outside of the 0 to 360 range, we're going to try to fit them into that 0 and 360 range. We're going to fit them into that, and then from there, we can use what we know to make everything work out. So before we think about the sine of 1001, we need to understand where does 1001 fit with this 0 to 360 range. So what we're going to do is move it to that place. So if by taking 360 degrees away continually until we get a number between 0 and 360, we're going to be able to fit it exactly where it would be, knowing that it's 1001. So we take 1001 and we take 360 away. Well, 1001 minus 360 is, let's see, 641 degrees. That's too big. We take away 360 again. This is going to be 281 degrees. So we're there. So we know that we're at 281 degrees. We're not all the way around the circle, but we are pretty close. We've moved quite a distance. So we've gone all the way around, and we're like now down here. This is like 281 degrees. So that's pretty good. So what we can say is that, without a doubt, that the sine of 1001 degrees is the same thing as the sine of 281 degrees. The only difference is that there's 2 rotations of 720, but they end in the same place. So instead of thinking of the 1001, I'm going to think of the 281, which is exactly something that I can deal with. So now we're thinking, okay, so how do I deal with the sine of 281 degrees? Well, the sine of 281 degrees, again, being down there, we need to fit it with something that's in the first quadrant. So if we look at the first quadrant, we think, okay, well, sine, remember, depends all upon its y value. So this is a negative y value. So it's going to be negative. Well, if I fit the same thing up in the top, the same sort of value, same sort of relationship, it's going to be a positive number now. This is a positive y. Well, it's going to be the opposite, right? It's going to give us the opposite. So how do I relate the two of these together? Well, they're both the same distance away from 360, or 0. If I do 0 plus, or 0 or 360 minus, because 0 and 360 are the same, I'm getting to the same place. So I need to think of how far back from 360 did I go to get to 281. Well, this is the same thing as 360 minus how many degrees? So let's think. So 60, 79 degrees is right. So this is the same thing as the sine of 281. Well, if I go back 79 and forward 79, from 0, I'm going to get the same thing. I'm not going to get the same thing. I'm actually going to end up with the opposite value. Instead of a negative y, I'm going to end up with a positive y. So I end up with negative sine of 79. So several things I did there. Not only did we take an angle back to something that I knew between 0 and 360, but I had to relate it to either 0 or 360, and that, taking away from 360 and adding to 0 give me the opposite signs, so I'm getting opposite answers kind of going backwards with sine, because it depends on that y coordinate, and I'm starting where y is 0. So several steps here, but think spatially before you do anything, and you can probably get very close to your answer and kind of get a better understanding of it. So negative sine of 79 is the right answer here. So I'm going to erase this. Now, the next one, we're dealing with radian measure. So I've got 23 pi over 8. Well, in radian measure, we all start with 0. If I rotate around, I get to what's known as 2 pi. Well, if I go around again, I add 2 pi again, which becomes 4 pi. Same kind of pattern that we noticed last time, that if we keep moving, we're adding 2 pi each time. So if we have a number that's too big, what we're going to do is try to fit it within our 0 to 2 pi. So we don't want answers that are that big. We want them that are in this range here, between 0 and 2 pi. Then we can deal with them just like anything else. So 23 pi, over 8. So that is closer to 3, right? 23 over 8 is closer to 3. So let's take away 2 pi. Well, in this form right here, it's going to be a little difficult, right? So I'm going to ask you to rethink about this. So if we have to add 2 pi or subtract 2 pi from an angle to make it fit, don't think of it as 2 pi. Think of it as 2 pi in terms of the first answer. Well, what's going to make this easy is, instead of talking about parts of 1, I'm going to talk about parts of 8. Well, 2 pi, if I'm dividing by 8, is the same thing as 16 pi. It's going to make things fit a lot easier if I just go ahead and think about the denominators as being the same. Okay, so if I take away 16 pi over 8 from 23 pi over 8, I'm left with a magic number of 7 pi over 8. That is between 0 and 1, isn't it? Okay, or 0 and 2 pi. It's in the middle of them, which is great. So I'm going to take away that, and I'm going to say, okay, well, where is my 7 pi over 8? 7 pi over 8, think about the 7/8 part, because pi is located all the way on the other side of 0 and all the way on the other side of 2 pi. So 7/8 is a little bit smaller, so I'm looking all the way over here. So this is like my 7 pi over 8. Now, I know that now I'm just going to deal with that because it's going to have the same properties as the 23 pi over 8 does. So now I can think about how does this work with my secant and all that kind of stuff to make this really, really fun. Well, the secant of 23 pi over 8, that's the same thing as the secant of 7 pi over 8. Unfortunately, that's not an acute angle. So I have to figure out, how does that relate to an angle back in the first quadrant? Well, this here has a negative x. Now, why am I talking about x's? Well, secant depends on the value of cosine. Cosine depends on the value of x, or where it lies on the xy plane. If I were to relate this back to a function on the other side, well, if I had a positive x, same sort of distance, I need to do something like this. Okay, so this is my positive x. Well, how do they relate to each other symmetrically? Well, if I look, I'm going backwards the same amount. So I can think, okay, so let me think, how do I measure, what is that white arrow? How much of an angle is that? So if I'm going backwards from pi, then I need to figure out, okay, so how much backwards from pi is 7 pi over 8? Well, again, think of pi as 8 pi over 8. Okay? 8 pi over 8. So if 8 pi over 8 is made up of 7 pi over 8 and some extra angle, what is that? Well, it's just going to be 1. 1 pi over 8, right? So what I'm going to say here is that this is the same thing as the secant of pi minus pi over 8. So the angle that fits into the first quadrant that the secant of 7 pi over 8 relates to is pi over 8. Now I have to decide, is that positive or negative? Well, if we look, since I'm going from a negative x to a positive x, I'm getting the opposite answer. This ends up becoming the negative secant of pi over 8. Because in order to get an angle in the first quadrant, the yellow line over there, I have to think about how does it relate to the 7 pi over 8. Well, 7 pi over 8 is pi over 8 back from pi, and going backwards from pi or going forward from 0, it ends up giving me the same sort of, same magnitude of x. It just gives me the opposite one. So this is a tricky thing that we're going to have to make sure we kind of keep working at, but very much think of this visually, and that's going to help you out.